welcome to the podcast of the European Young Chemists Network, EYCN. My name is Mark Kalada and welcome to our new series. In this series, we interview the winners of the prestigious European Young Chemist Award 2020 to discuss with them their research and also ask them for advice for other young chemists. Today, we are talking about an easy and fast solution to measure possible water pollutants right at the source without the need of expensive experiments in a chemical laboratory. For this, our Dutch delegate Koen van den Helder interviewed the gold medal winner at the PhD level, Dr. Eoin Murray. Dr. Murray is the Research and Development Manager within TELLab, an analytical chemistry and chemical manufacturing company based in Ireland. Eoin received a bachelor degree in environmental science from the University of Limerick and a master's degree in analytical chemistry from the University of College Cork. Eoin's PhD in analytical chemistry was industry-based and was affiliated with Dublin City University and the Australian Centre for Research on Separation Science, University of Tasmania. Eoin received 2 scholarships for his PhD, which was focused on developing portable chromatography systems utilizing microfluidics and LED-based optical detection for the analysis of water pollutants such as nitrate and nitrite in natural and industrial waters. The portable analyzer developed during Eoin's PhD has been successfully trialed in Europe and the US and is currently being commercialized. Eoin is currently leading a team of chemists and engineers developing new portable analyzers and technologies for the on-site monitoring of a broad range of pollutants in environmental waters.
Eoin, thank you for being here and doing this interview with us. So as we heard in our introduction, you did a master in analytical chemistry at the University College in Cork. You did your PhD in Dublin. And so why did you go into chemistry and more particularly analytical chemistry anyway?
Sure. So I've always had a passion for science and an affinity for biology and chemistry, even at a young age. And my bachelor's degree was in environmental science, and it was quite a broad program. So I kind of got a flavour of a whole range of different areas. But the areas which I kind of had most interest in and enjoyed the most really was chemistry and specifically analytical chemistry. At the end of the program then, a lecturer who I admired a lot recommended that I go for a master's in analytical chemistry in University College Cork, it was a nice program, good program, so I said I'd go for it. During that program then, as part of the master's, there was an industry-based research kind of period. So we're placed in a industry and he carried out a research thesis for the masters, and it was within the company that I'm working for at the moment, and it was in around portable kind of test kits and in the area of water analyzers and things like that. So that's kind of where the work started. Following that then I was offered an industry-based PhD on the back end of that masters, and again, it was in the area of water analysis and analytical systems in that area. So that's kind of how I fell into this area, and I've been kind of working in the area since.
Yeah, so you kind of rolled into analytical chemistry eventually.
Yes, yeah, it was an area which I kind of had an interest for, and yeah, it drew me in really. Yeah. Okay.
That's very cool. So you already mentioned your industry PhD, in which you developed a portable IC system. Could you tell me a bit about this system?
Yeah, so the analyzer, it's designed to be a portable analyzer to be used in various applications in the water sector. So the system is to be deployed on site or in situ next to the water to be analysed. So in wastewater treatment facilities or surface waters such as rivers, industrial process waters, those type of applications. And the analyzer, it generates concentration data specifically for nitrate and nitrite. and it generates data in real time and communicates this concentration information back to the user. So essentially the user can make informed decisions based on that information. How the analyzer operates, it's, as you said, it's based on ion chromatography or IC, so it's a chromatography instrument, and basically it's an analyzer which carries out a separation of charged pollutants or chemicals, in this case nitrate and nitrite, and through a simple rapid separation it allows for the selective detection of nitrite and nitrate. So that's kind of a high level overview of what the analyzer is and how it works.
So essentially you developed a on-site machine which can analyze nitrate compounds in really short words. So
yes.
So why is this important? Why is there a need for this type of analysis?
At present, the kind of gold standard for water monitoring is an individual would go to site and take a grab sample, or basically take a sample from the water source, bring it back to the lab and generate the results, and you'd have the results in a couple of days. The issue with that is, say you take a sample on a Wednesday at 12 o'clock, take the sample to the lab, analyse, get your results days later. At 1 o'clock on Wednesday, there could be a pollution event, and you've essentially missed that pollution event. So you can see the issue. It's just simply not good enough for effective water quality management. So really, to be able to control water pollution and achieve high levels of water quality, you need real-time information and concentration information over time. And that's why there's a need for analyzers like this. There is a handful of commercial analyzers that can do this. The issue is they're very, very expensive, and it basically inhibits the use at mass scale. So they can't be used. They're not really suitable for mass adoption at those price points. In addition to that, they're quite complex to manufacture, so that's another issue. So that's where a system like this comes in. And the idea is that it's low cost, easy to mass manufacture, and also achieves high levels of analytical performance as well.
Okay, that's very nice. So it measures then continuously. You can just place it in some spot and then leave it there for ages to analyze the nitrogen compound.
Yes, so several months at a frequency of 6 times per day, but it can achieve an analysis every 15 minutes depending on the application.
And that's very good. So, and you don't need any sample pre-treatment for this analysis?
No, it's a robust method. Literally insert the sample intake into any water sample, basically any water sample, and that's it. 5 minutes later you have your concentrations, and you can access the system and the information remotely via a web portal or an IoT platform.
That's, I think, very cool. But you were mentioning several other products available on the market will also analyze nitrogen compounds. And what makes your product more innovative and therefore cheaper than the other products? What makes it better than the other commercial available products?
So the competitor products a lot of them would be based on an approach called colorimetry. Basically, colorimetric chemistry. It's you use a range of various chemicals and reagents it generates a reaction that forms a color. The intensity of the color then is proportional to the amount of the nitrate and nitrite in the sample. The systems, they work reasonably well. The issue is they're quite complex to control the reaction. You need considerable levels of engineering to achieve robust analytical results over time. So besides the fact that the chemicals are hazardous as well. So that's one aspect to it. There's other systems then that use UV lamps and things like that. Again, they're expensive. They have issues with fouling and analytical drift over time. Where our system is different is it uses a rapid separation approach. So the issues around fouling and things of that nature, they're not really as significant versus the UV probes. And then compared to the colorimetric analyzers, we're we can achieve high levels of selectivity, and the analytical calibration holds over time as well. So it's more robust on that side as well. In addition, it's a basic and simple unit. So there's just a handful of pumps, some valves, and a small column and a small detector. So there's only maybe 5 core components, and the colorimetric based systems have a lot more fluidic control and requires a lot more engineering really to get it performing well.
Yeah, it sounds there could go much more wrong in the other analyses. But actually you changed kind of the chemistry in which way you measure the nitrogen compounds. Why are you the first person to come up with this change of chemistry, or why didn't other companies already did this?
Yeah, so it's portable ion chromatography systems have been developed in the past, and typically, like the systems, they just used lab-based components and instrumentation to try and bring those systems into the field, and it didn't really work very well because it's of course high cost and high energy requirements. And typical IC systems, they use conductivity detection, which is heavily impacted by temperature variations, which, as you can imagine, it's an issue when you're in the field. So what we did, which is unique, is it all comes from the UV LED optical detector. So a couple of years ago, maybe 2 years ago, a deep UV LED, which has at a wavelength of 235 nanometers, but it's a deep UV LED anyway, that came onto the market. And essentially what that allowed us to do was to selectively detect nitrite and nitrate. By developing that detector, we were able to use kind of a simple separation column which had low back pressures, and then that allowed us to use simple pumping, and so the whole system, it's the simple nature of the system all stems from that UV detector, and that's really where the novelty comes in, and we have a patent in place around that technology, but it's all really enabled by that detector.
Yeah, so you're actually kind of lucky that this detector came on the market, and that made it eventually that you managed to make this nice machine, which is already used quite a lot, I saw. And many countries already use it. Why is it important to use it?
Yeah, so in terms of the deployment, so we had, during the course of the PhD, we were involved in a European funded project through it's called the LIFE program. But the project was these types of systems, nutrient, pollutant analyzer systems, were to be used within various wastewater treatment facilities mainly, but other water applications as well. So this prototype version of the system was deployed in Spain, Finland, Ireland, of course, and other places as well. We had some systems in New Zealand, but they were the prototype versions of the system, and it was really many. I think we had 27 or 28 systems at various sites, and it was kind of an early adopter demonstration of the technology and the analyzer, and we gained huge amounts of information from that, and from those deployments we're in a position now where over the past year we've taken all the learnings from those deployments, and the system is basically, the commercial product is made now, and the commercial launch will be mid-February of next year. So all of those deployments, they were prototype systems, but again, it was invaluable information prior to the commercial launch.
Yeah, of course. That's very good. So, and I was actually wondering, in your presentation for the EYCA, that's a prize you won for this project, you showed on a map that there were a lot of these prototypes deployed in Spain. Why is Spain so special to analyze nitrogen compounds?
Yeah, so Spain there was a number of Spanish organizations involved in that European project, which we were in. And Spain, really, they're leaders in wastewater treatment technologies and innovations. So they're really heavily involved. A lot of organizations are work in that space. And that was, so I think we had several organizations that were kind of scattered throughout Spain involved in the project, and that's why there were so many units deployed across Spain. had also had some units in Finland, and we had two units in the US in Massachusetts, and that was part of it was a competition organized by the US EPA called the Nitrogen Sensor Challenge, and we were finalists in that competition as well. So yeah, it was quite a enjoyable time really. It was a lot of travel and a lot of deployments.
Yeah, you made sure you had a lot of outreach with your project, which I think is really good in chemistry. And you did an industry-based PhD, which is of course different than a PhD only in academia. In which way did you benefit from doing this industry PhD? Did this industry PhD made you achieve things you couldn't achieve working only in academia?
Yeah, I think there was definitely pros and cons. Some of the negatives, especially at the early stages anyway, I felt a bit isolated at times, especially at the beginning of the PhD. It was quite a small research team, and trying to figure out which direction to take things was challenging. I felt, I was kind of on my own. But then as things progressed, it started to come together nicely. I would say the benefits were mainly around the kind of financial side of it. Because I was an employee, I had a salary in combination with scholarship, so that was really helpful. In addition then, in relation to conferences and presentations and things of that nature, the company was very supportive. So I could go to whatever conference I wanted and present. There was no restrictions there, so that was really good. And I think the most important aspect was the fact that it was so commercially driven, and any development or what I was doing was all at the back of my mind was, I'm trying to address a gap in the marketplace and, trying to ultimately generate a commercial product. So I found that really, really interesting, and there was a big push on the commercial side, not just research kind of for the sake of research. So it was exciting and challenging as well, but I enjoyed that side of it for sure.
I see. Do you think it should happen more often that we do more PhDs combined with academia and industry?
I think there's a place for it. I think PhD and research in academia definitely has a lot of benefits though as well. I mean, the fact that you're surrounded by postdocs, many professors, high levels of expertise and support. I think it's very beneficial as well. So I mean, there's probably a place for both, but potentially it's probably down to the individual as well. It can be quite challenging. I suppose depending on the industry you're in as well, but at times it can be very challenging and kind of isolated when everyone else it's just a job for everyone else, and then you're trying to balance job with your PhD. It can be quite tough.
Yeah, I can see that. So looking back on your PhD, was there something you would have done different? Something that younger PhDs could take as a sort of advice?
Well, I can't. I mean, I can't think of anything I would have done differently. Really, no, I don't have anything on that one. I mean, I'm quite happy with how it went. Some things didn't work out, but I mean, I probably wouldn't change anything.
And then you had a good PhD, I think. And eventually your PhD led that you have a job at the company where you work together with your PhD. You're now head of research there. So from here on, what are your further goals in your career? Where do you want to end up in like 20 years or so?
Yeah, so I suppose besides the obvious kind of eagerness to publish and papers and patents and things like that, so that's always going to be there, I suppose. But in the short term, I'm working on project management, so PMP certification just for myself. I think it's helpful for managing various projects, and down the road at a senior level, I think it'll be beneficial. In the kind of beyond that then, so we're commercializing this version of the system. We also have iterations of this version in the pipeline, and then beyond that we have other types of analyzer that we want to develop and commercialize. So the goal there is to basically generate hopefully as many commercial products as possible, and really fill the market gap that exists for these types of systems, and then down the road just to be a global leader in this area, in the area of water quality and water monitoring. That's my long-term goal anyway.
Yeah. So staying in industry.
Yes, I would say for the next number of years anyway. I would think so. Yeah.
Okay. And then maybe once you go back to industry to publish more, or to academia to publish more. So to conclude our interview, do you have any advice for our younger chemists listening regarding their future in chemistry?
I would say read and absorb as much as possible, not just from a chemistry side, but even when considering analytical chemistry, for example, it's beneficial to have an understanding of other areas. So even a basic understanding. So engineering on the mechanical side, electronics, data processing, especially when considering analytical chemistry, it's at times it's a cross between many different disciplines. So I think it's very beneficial to have a basic understanding of different areas, and I think that can set you apart. Yeah, and in addition, then I suppose there's always more to learn. There's always more to understand, and it's really important to always be curious and wanting to know more and wanting to understand more. So that's probably what I would say.
So absorb a lot of information and learn as much as possible.
Exactly. Never be satisfied. Always be curious and wanting to know more. I think that's what science is all about, really.
Okay. Well, thank you very much for joining us for this interview, Eoin. It was a pleasure to meet you and a pleasure to interview you. And thank you for your nice words.
Thank you. My pleasure.
Hello, it's Mark here again. We hope you liked the second edition of our new series. Stay tuned for the other two winners and feel free to listen to the previous editions. Please, as always, leave your feedback by rating our podcast, and if you have any questions or further remarks, you can also send us an email at podcast@eycn.eu. See you soon.